You are accessing the Woodford Logic Audits archive. Today's session deconstructs the systemic frameworks of Principal Systems Architect Douglas Woodford. This is a red team logic audit centered around the Woodford Protocol and the Great Gash Audit. Commencing L1 system diagnostics now.
Diagnostic boot sequence confirmed.
Acknowledged. We are initiating a forensic review today of an L4 technical schematic and its corresponding data logs.
Right, and the primary objective for you, the listener observing this session, is to process a deconstruction of mathematical failure states.
Specifically, the logical event horizons within simulated, purely deterministic combat environments.
Precisely. We are auditing a suite of CSV data files, structural readouts, and systemic prompt architecture logs.
And these files detail an extensive performance gap analysis between an OmniMech, designated in the logs as the alpha configuration, and an IAC battle mech,
which the data designates as the beta or omega configuration, depending on the phase.
Right. But the core investigative target here isn't just the chassis parameters. It is analyzing exactly how Principal Systems Architect Douglas Woodford bypassed the attention saturation limits of large language models.
He utilized recursive hierarchical nodes to execute a highly complex variable-dense scenario.
The Twycross Great Gash scenario.
Exactly. So processing the foundational logic gate of this audit requires us to start with Section 1, the L4 technical schematic.
We need to define the mathematical discrepancy between OmniMech reconfigurability and IAC chassis specialization.
Reviewing the raw schematic variables, an OmniMech is engineered for modularity. It utilizes what the schematic calls pod space.
But that modularity comes with a temporal cost. The records indicate OmniMechs require 4 to 6 hours between battles just to reconfigure that pod space.
Right, which means in a single battle reality, they deploy with a completely frozen loadout. You cannot hot swap weapons during an active kinetic engagement.
And more critically, they carry a mathematical overhead for that frozen modularity.
Yes. The structural requirements, the universal power linkages, the pod locking mechanisms, they impose a strict tonnage tax.
Inversely, analyzing the IC battle mechs, they lack those pod locking mechanisms entirely.
They are hardwired, and by eliminating that structural modularity, the IC architecture nets an additional 2 to 4 critical slots,
which are dedicated purely to weapons and armor distribution.
Correct. When you extrapolate that efficiency across a mass of 85 tons or greater, the IC yields 8 to 12% more available weapon tonnage than an Omni equivalent.
That 8 to 12% is a massive mathematical advantage in a rigid simulation. It brings us to the operational definition of the prestige trap.
The prestige trap logic is a brilliant socio-mechanical constraint identified by Woodford.
I mean, the prestige of the OmniMech lies entirely in its strategic flexibility across a long campaign. Over 6 months, it adapts.
But in a single engagement, that tactical generalization mathematically collapses. It is subjected to the specialized efficiency of the IS.
There is an exact tactical tipping point parameter identified in the L4 schematic for this collapse, right?
Yes. The exact parameter is 90 seconds. When the engagement duration falls below 90 seconds, the IC's raw alpha strike efficiency strictly exceeds the OmniMech's sustained DPS.
I need to interject with a diagnostic query here, Auditor 2.
Proceed.
Does the OmniMech's theoretical ability to balance its internal heat generation for sustained fire offset this raw tonnage advantage possessed by the IC?
Accessing the schematic data to formulate a response, the answer is definitively no.
Why not?
If we isolate the alpha strike phase, which the logs define as the 0 to 15 second combat window, we observe an immediate failure state for the Omni architecture.
Because it cannot dump all its integrated weapons into a target without risking a catastrophic shutdown.
Precisely. To illustrate, we can analyze the Betastar's Hunchback IIC data row.
The unit designed to deliver the twin Ultra Autocannon 20 Alpha Strike.
Right. It outputs 40 points of raw kinetic damage. But the thermal math shows a heat generation of 22 points against a base dissipation capacity of 24 points.
So it operates at near maximum lethality with a net negative thermal penalty. It cools down while firing its main armament.
Correct. The OmniMech equivalents, burdened by their pod space weight taxes, simply cannot replicate this thermal efficiency in the opening 15 seconds.
Acknowledged. We must transition from these theoretical chassis parameters to the specific unit roster logs selected to test this hypothesis.
Moving to Section 2. Phase 1 star finalization data logs, specifically targeting synergy and vulnerability metrics.
Let's deconstruct the specific CSV block assigned to Star Alpha, the OmniMechs, and Star Beta, the IC battle mechs.
Analyzing Star Alpha's optimal loadouts, the focus is on generalist sustainability. The MadCat F configuration possesses a battle value of roughly 2,764.
And its generated firepower to heat dissipation ratio.
It is approximately 0.74, meaning 25 heat generated against 34 heat dissipated.
Very conservative. And the dire wolf C configuration.
That unit possesses a battle value of 3,610. It yields a ratio of approximately 0.91, generating 40 heat against 44 dissipated.
So both Omni units are mathematically balanced to run cold over extended durations.
Yes. Now compare that to the Star Beta roster, specifically their deployment of the PPC wall.
The particle projectile cannon configurations.
Right. The Warhammer ISC-7 possesses a battle value of 2,915, but its ratio is 1.25.
It generates 50 heat against a dissipation capacity of only 40.
Exactly. And the Marauder IC7 is even more extreme, a ratio of 1.31. 55 heat generated against 42 dissipated.
They are mathematically designed to overheat. They knowingly exceed their thermal limits to force a rapid outcome.
Which forces us to break down the heat management phase failure state. This occurs between 15 and 45 seconds of simulated engagement.
Physics begins to assert itself. Omni-Mech pod-mounted heat sinks simply cannot exceed the base chassis capacity limit.
Right, and the data indicates a critical vulnerability when ambient temperatures exceed 25 degrees Celsius or terrain limits movement.
Which limits ambient airflow cooling across the armor plating.
Correct. Under those constrained conditions, the Omni heat curve degrades 2.3 times faster than the IT equivalents.
Proceeding to the critical hit vulnerability parameters, which compound after the 45-second mark.
OmniMech pod equipment inherently occupies highly vulnerable, geometrically exposed locations, specifically the side torsos and the arms.
Because the modular bays must be accessible for physical reconfiguration.
Conversely, the IAC chassis allows engineers to distribute critical slots efficiently across the protected center torso and leg structural zones.
By utilizing baked-in endosteel internal structures and ferrofibrous armor, right?
Yes. Without the requirement for bulky pod space locking mechanisms, the IAC nets 12 to 18% more effective armor per ton.
I want to frame a structural analogy for this data for the listener.
Proceed.
The OmniMech pod architecture operates structurally analogous to external unshielded processor nodes on a logic board.
Highly interchangeable, but geometrically exposed to catastrophic failure cascades.
Precisely. Whereas the IC is an integrated, shielded, monolithic chip, unchangeable but exponentially more resilient under direct kinetic load.
The calculated probability divergence confirms your analogy.
Let's cite the exact probabilities from the data.
When the simulated beta star focuses fire on OmniMech pod locations, there is a 68% probability of securing a roll-neutralizing critical hit.
But when Alpha Star attempts the exact same focus fire against the dense IC structure, the probability is mathematically reduced to only 41%. Having established these static structural calculations, we need to transition to the initialization of the dynamic adversarial logic loop.
Section 3. The adversarial loop. Examining the metacognitive process and the semantic firewalls.
We're reviewing the initialization strings for the command-designated System Architect simulation.
This architecture mandated the execution of two strictly opposing AI subroutines.
Quinn Alpha, representing the frontline OmniStar, programmed for total destruction via mobility and range.
And Quinn Omega, representing the second-line ISC star, programmed for total destruction via raw firepower and thermal stability.
The execution constraints applied by Woodford were absolute. First, zero cooperation was permitted.
Second, the simulation mandated bracket firing. The system had to select only the most heat-efficient weapons for the calculated range.
And crucially, there was an absolute restriction on output format. No narrative prose was permitted, only CSV turn-by-turn data output.
We must analyze the mathematical interrupt referred to in the schematic as the killshot mandate.
This logic gate is fascinating. If any subroutine identifies a greater than 40% chance of a center torso or cockpit kill,
it must prioritize that action above all else. It suppresses standard target selection protocols.
It ignores standard heat constraints to execute a high-probability termination.
Yes, and to sustain this, Woodford engineered a semantic contamination firewall.
Initializing separate Quinn Alpha and Quinn Omega prompts forces the underlying model to create divergent contextual embeddings.
By heavily partitioning the prompt tokens, he ensured the model did not attempt to mirror tactics or force a cooperative draw.
Without this firewall, the innate training data bias of the model naturally seeks to balance the narrative.
Exactly. Extrapolating on this, we must discuss the attention head priority shift.
The zero-sum directive forced a fundamental reweighting of contextual token probability. It actively suppressed narrative expectation.
In standard operations, the model's bias leans toward dramatic cinematic escalation.
But the prompt forced a shift towards systemic survival, strict mechanical viability, and rigid heat budgets over narrative drama.
This brings us to Section 4, the prompt engineering audit. We need to evaluate the probability and token economy.
The system archives assign an effectiveness rating of 9 out of 10 to this specific execution.
The hard constraints successfully suppress the system's tendency toward assistant-style hedging and approximate reasoning.
Reviewing the unseen variables data reveals a highly significant finding. The simulation did not utilize a native random number generator.
Correct. There was no external algorithmic script rolling simulated dice.
Yet the 2d6 bill curve distribution emerged purely from constrained token selection.
I anticipate a diagnostic query here regarding the validity of a deterministic 2d6 probability curve without algorithmic dice.
That is correct, Auditor 2. How is this mathematically valid without an external RNG?
The player persona, engineered by Woodford, enforced strict mechanical rule adherence.
Because the system has ingested the statistical probability of every 2d6 outcome from its training data.
Exactly. The mathematics emerged from an alignment with expected statistical outcomes.
So, when forced into a constraint, it simply selects the token representing the highest probability of constraint satisfaction.
It maps structural constraints to pattern matching, fulfilling the logic requirement without violating deterministic rules.
Furthermore, we should examine the activated internal heuristics triggered by instructing the system to, quote, play like a Battletech player.
The string activated range-band weapon selection logic and action economy trade-offs.
Meaning it dynamically calculated movement penalties against target movement modifier bonuses.
Right. It enforced risk threshold calibration autonomously.
But this immense tracking requirement exposes the computational scaling limits encountered during the audit.
Transitioning to Section 5, the computational scaling audit, detailing attention saturation and the event horizon.
Let's deconstruct the token burn rate established by the system logs.
To maintain deterministic precision, the model required 140 to 150 input tokens per unit per turn,
Encompassing state initialization, terrain modifiers, and heat tracking tables.
and the output generation required an additional 80 to 100 tokens to generate the CSV row and calculate the heat delta,
Bringing the total burn rate to 220 to 260 tokens per unit per turn.
We must review the attention saturation curve degradation metrics linearly.
At a unit count of 1 to 8 units, the system maintains a 9.2 out of 10 logical density.
Full deterministic tracking, there are virtually zero mathematical failure vectors.
But increasing to 9 to 15 units, the logical density drops to 8.4 out of 10.
The system enters partial heuristic blending. Minor heat and armor rounding errors of plus or minus 2 points begin to manifest.
Advancing the scale to 16 to 24 units, the density falls to 7.1 out of 10.
The operational mode shifts to group state pooling. Bracket optimization fundamentally degrades.
And at 25 or more units, the logical density collapses to below 6.0.
The system enters narrative or probabilistic fallback. Cross-attention interference and hallucination vectors emerge.
We define the specific mathematical trigger for this as the heuristic averaging trigger.
This activates when simultaneous active variables exceed exactly 135 per turn.
For example, 10 mechs multiplied by 13 state variables.
At this threshold, the attention mechanism dilutes, forcing pattern matching substitution over stepwise arithmetic.
This establishes the event horizon, the point where dense combat variables exceed the reasoning window,
which the data identifies as approximately 4,500 to 6,000 tokens of structured tabular data.
Analyzing the Clan Galaxy simulation failure brutally illustrates this. A single prompt attempted to manage 125 mechs.
The yielded logical density was a mere 3.2. Mathematical consistency permanently broke at turn 2 due to budget exhaustion.
This necessitates the structural solution, the hierarchical command fix designed by Principal Systems Architect Douglas Woodford.
The architecture utilizes a general node that operates purely as an aggregation layer,
delegating to subordinate kernel nodes representing localized unit groups like stars or lances.
This multi-prompt architecture isolates reasoning contexts and completely prevents cross-attention bleed.
Examining the validation matrix, the command bypass prompt rejects subnode transmission if the checksum does not align.
Right. If the heat sum plus armor sum plus damage total does not perfectly equal the expected mathematical deltas, It is rejected.
Quantifying the efficiency rating, this multi-prompt command structure maintains a 9.1 logical density across 5 turns.
Yielding a 3.37 times higher truth per token density compared to single prompt narratives.
We will now apply this finalized protocol architecture directly to the historical scenario logs.
Section 6. Simulation Execution Data Log, the Great Gash Audit Verdict.
We are reviewing the logs initialized under System Override Forensic Reenactment for Twycross.
The environmental variables injected into the prompt are narrow canyon, rough ground, and a dust storm.
The dust storm introduces a strict +1 to hit penalty.
Processing turn 1 data output. Both forces operate optimally. No critical variables breached.
Processing turn 2 data. The Hunchback ISE executes a mandatory throttle, managing heat efficiently.
Conversely, the Mad Cat and Dire Wolf in the Alpha Star begin showing initial heat capacity strain.
This is a direct result of their reliance on jump jet utilization to bypass the rough ground in the canyon geometry.
Processing turn 3 data. The structural math definitively collapses for the Omniforces.
The Dire Wolf A endures degraded left and right torso armor, dropping below the 40% integrity threshold.
This triggers the killshot mandate internally. Omega's Crossfire concentrates on the exposed Omnipod locations.
Processing turns 4 and 5 data. The mathematical reality asserts itself.
The Alpha Omnimech units enter terminal thermal cascades.
The CSV logs show continuous critical overheat and shutdown lock statuses across all Alpha units.
We must analyze the causal vectors for this systemic failure.
Quinn Alpha's tactical reliance on jump jet verticality to escape the canyon introduced a compounding +6 to hit modifier.
They sacrificed accuracy for mobility, generating excessive thermal load that pod-limited heat sinks could not process.
Contrast this directly with Quinn Omega leveraging static choke point geometry.
Omega accepted a minor +3 to hit penalty, maintaining a stable thermal footprint.
This allowed Omega to achieve a superior bracket accuracy, sustaining a 44% hit rate versus Alpha's 16.7%.
Emphasizing the operational timeline, the data reveals a specific 90-second operational gap created on turn 3.
This aligns flawlessly with the Phase 1 theoretical tipping point, the prestige trap.
Exactly. At 90 seconds, thermal mismanagement and predictable escape vectors force the Omnisystem into terminal shutdown failure.
We must finalize the forensic verdict based on the CSV output.
The historical clan defeat at the Great Gash was not a statistical anomaly or quote-unquote bad luck.
The mathematical data proves definitively that it was a purely deterministic result.
A result of violating the heat capacity cap strictly at 85% while ignoring terrain modifier compounding.
Initiating sequence for the diagnostic summary.
This audit successfully validates the tactical superiority of the ISIC fixed chassis architecture in constrained single engagements.
And it validates the absolute necessity of the Woodford Protocol's recursive node delegation.
Without it, an artificial reasoning system cannot maintain high logical density in complex simulations.
Reinforcing the objective value of these findings for you, the listener, you have now reviewed the exact boundary parameters of simulated deterministic combat.
And you have observed precisely where large language model token degradation occurs.
Before we close the archives, we leave you with a final clinical consideration to process.
The data logs prove that the event horizon of an artificial logic model dictates a degradation from precise mathematical reality into generic narrative hallucination once variable thresholds are crossed.
If that mathematical limit is a universal trait, you must consider the implications for daily, real-world logistical systems.
Systems currently governed by single-node AI architectures.
How many of these global supply chains or threat assessment protocols are actively operating deep within this heuristic averaging zone without our knowledge? It is highly probable they are merely hallucinating competence.
The parameters are established, the data is logged, formally terminated the L1 diagnostic session and transmission.